be blunt, be clear, because don't want to be perfect, we want to be perfect enough.
Builds the most complex tool in the world, the EUV machine, focused in the spotlights of the general audience and also of the politician.
Thank you for introduction. My name is Dr. Shiba, and Mark, I'm so glad to be here with you.
No, likewise. Thanks for having me.
So I spent last New Year break. Really too good, by the way.
Okay.
Yeah.
So just in one day you read it?
No, actually it took 3 days.
Oh, okay.
The way I took this book is that you are talking a lot about innovation in a Dutch way, and how Dutch people bring that technology into commercial scale, and also that collaborate with so many other eco partners. And for those of you who have not read this book yet, I kind of like to talk about your book in 3 sessions. I think I have like a half an hour.
We're okay.
Okay. So I think we're in the first phase of ASML. Kind of starting when they met with Morris Chan, right? I believe it was 1987. Around that time, also kind of surprisingly, Philips was the became a major investor in TSMC.
Yes.
Right. Then this is also ASML began its collaboration with Carl Zeiss. It's a really fascinating combination of Dutch, being very direct, right, and German, more like polite and
we Dutch can be polite as well. If you pay us well, we'll be polite.
Yeah, kind of made it fun, So it was a very, also that interesting part of this equation is that they wrote a lot about Martin.
Yes.
And I know Martin, for, I don't know, almost like 10 years. So, he's pretty much known for very exceptional technical insight and also very direct, but really the thing is that, Philips has been pretty much supporting all the RA product innovation, but they left, kind of from TSMC, the adventure from ASML. But I think really overall, Philips has been a very kind of play a central role to drive. Can I follow up on that? Sure. So I like to ask you, if I'm right or not.
Well, if you look back at the history of ASML, we tend to think of this company as a very successful and rich and valuable player. But back in the day when it was kicked out of Philips, it was on the verge of bankruptcy for like 3 times. And often Philips was like the savior. There was one time when ASM Lithography, so the Arte del Prado company, had to step out, and Philips reinvested in ASML, and it also provided a loan, this very crucial loan for the company to survive and invest in new technology. And if you look at the heritage of Philips, it's also in the mindset, and I think one of the funniest examples of that is that all the product names at ASML, so every litho tool consists of hundreds of thousands of ingredients, of little parts. Every part is named the same way with the same number as back in the Philips days for 16 or 17 years. So they never bothered to change that nomenclature. And Martin van der Blik was very much aware that technology at ASML didn't start in 84 or 87, but it started back in the 70s with Philips, and also it was very rewarding to the Japanese and the American researchers that also provided the foundation of this industry. But what made Martin so special, and that's why he's the protagonist of the story, is that he's like the combination of being direct in a Dutch way, multiplied by being direct as a leader, multiplied by the fact that he is a bit autistic as well, and he's brilliant. So that makes it a challenge to deal with him. But once you get to gain his trust, then it's a very awarding and giving person who gives you a lot of new insights. And for me, it was also an inspiration. And he kind of captures the culture of ASML way of open innovation. I want to ask him, so he could be very relaxed with security concerning himself. So he often forgot his laptop on the plane, or forgot his wallet or his phone. He left it in a cab in Taipei.
Passport.
And the passport, of course. And this is the guy running the most valuable technology company in Europe, and he just didn't care because he didn't want to waste his time thinking about the mundane things. He wanted to. He was this visionary of having his open innovation, because open innovation and being transparent is the only way to get to this next level of advanced compute. And he was also very direct to customers. So he was the one telling customers, you don't need this technology. Just wait a second. For your solution, you might have a better option with another, maybe cheaper tool. And he also said, you think you're happy that we solved EUV? Wait for the other problems we are going to encounter. So he was basically too honest for his history.
He was.
He is. He's still involved.
He's still-
Yeah.
So, I think, then, back to the question about the Philips. I don't know why Philips has been supporting so successful companies in the semiconductors, but they just got out from semiconductors back there, in those days.
I think let's wind it back. So one of the reasons why ASML is successful is that it was considered a neutral player. So many of the competitors of ASML were Nikon and Canon, and they were too closely connected to, Japanese semiconductor manufacturers like Toshiba, Sony, or Edison, in the American mindset. So ASML was like a neutral player because the Netherlands didn't have a huge manufacturing capacity within their own borders. So that's one thing. The other thing is that this market is so capital intensive that you really need focus to target all your capital and talents on this very complex machine. And litho is just one part of the piece of the puzzle. If you look at the other players, like Applied Materials or TEL or Nikon, they really have to up their games when it comes to investing in new R&D for the next generation of this industry. And it's hard to do so in a conglomerate or in a company that's a bit bureaucratic, and you need the speed and innovation and short lead times of the semiconductor industry. So for Philips to fulfill that role would have been impossible. And let me just end my train of thought. So the reason that Philips got into TSMC was that it had technology processes that were kind of the legacy of a failed subsidy project called Megabit. It was a huge project by the Dutch and the European government and the German government, and they all kind of were hoping to get back to the semiconductor industry and memory chips, but they failed. But the end result, that Philips had interesting technology for TSMC, and that was the basic segue for ASML to enter TSMC. If you look back at the value stack I just showed, then the cooperation with TSMC is like the basic stack that NVIDIA and Apple now use to produce their products.
So let me talk about the second phase, ASML journey. Just by reading your book, the second phase kind of started around 1995 when ASML secured a single business from Samsung. And I think at that time that their competitor had some technical issues. Also around the same time, ASML was listed on Nasdaq, making a new stage of growth. So after the dot-com bubble burst in 2001, ASML made a bold move by acquiring SDG with a strong backing from Intel. The move was really kind of surprising Nikon. So in your book, you highlighted how difference in manufacturing discipline shaping a competitive gap between two countries, like the Japanese and Rush, ASML, Nikon, or even Canon. So at this point, I kind of saw that ASML is more like taking a UDA type approach as opposed to PDCA type approach. They just try to deliver something minimum to the customer, then they brush up technologies. That also kind of made difference, between the Dutch and Japanese companies. So I think we're aside from like ASML has done a good job to create the ecosystem. I think the way that ASML does really that implying a lot to us. How we can really foster innovation here in Japan. But in the say deep tech, I think really how do you think about it? The way that there's approach to the market, approach that new technology, things like that.
Well, you raise an excellent point because if you look at the way the Dutch engineers or Dutch audiences in general look at Japan, they're fascinated by the urge for perfection, and that's one of the reasons why Japan has become such a huge player in all these kind of technologies that we use in our daily lives. What differs at the ASML approach from Nikon or Canon, of course, first of all, Nikon and Canon are like conglomerates and they mainly use their own supply base, and ASML was more agile because it used the ecosystem and it just could afford to spread out its risk and keep R&D levels high. So that was an advantage. But there was also a different mindset coming back to the perfection. I think it can be captured in one sentence. Then I heard one of the ASML researchers say, it's we don't want to be perfect, we want to be perfect enough. And so that gave ASML a kind of a first position in the fab to start experimenting together with the customers and creating a closer relationship, and also beating the lead cycles of many of the competitors. And following up on your point of Samsung, I think one of the main reasons that Samsung was open for a competitor for Nikon is that Nikon was having issues with its litho tools in Korean fabs, and it wanted to shield off their technology. So they wanted to repair the machines or maintain them, but they didn't want to involve the Samsung engineers. And Samsung was also, well, it has a Korean culture, and they really wanted control over the technology. So they found it very hard to digest that one of their suppliers wasn't willing to share their knowledge. And I think ASML has fostered more of a cooperative spirit if you look at all the players in the industry. But correct me if I'm wrong, what do you think about it?
Actually, I had the same experiences in Korea, right? And South America Samsung engineers I think the way they approach the technology is different from Japanese. Certainly for Japanese, that's your job, and until your job, there eventually things will be all right. But in Korea, certainly it's hard. Right? You're not going to go home until you fix it.
Well, I think in a chapter about Korea is exactly that title. We don't go home.
Yeah, exactly. So therefore, you better be transparent and just share. You're pretty much on the same boat.
Yeah.
That's the kind of way to do business in Korea. And like photoresist, we do have like a voodoo chemistries, right? And it's kind of really difficult for us to explain. But really, the thing is that
So you use the term voodoo?
that's why I took
So you use my voodoo. Okay.
Exactly.
Let me explain to the people. I coined the phrase voodoo because Martin van der Brink, the CTO, used it to describe AI, especially language models, because it's like a black box. You don't know when you ask a question to Perplexity or ChatGPT. Well, you get an answer, but you don't know how it's created. And it kind of messes with the mind of an engineer or a physicist because they want to be able to explain things. And if you depend on AI, that's very hard to find the logic. But there's also voodoo in chemistry, of course.
Yeah, of course.
There's voodoo everywhere.
Yeah, I think chemistry is more analog than digital.
Yeah, okay. But Noble, I'm allowed to quote you, Noble. That's, for me, it was striking to see how much analog elements are still in this digital world we perceive. So if you drill back to the core elements of semiconductors, then it's still chemistry, it's physics, it's yield, it's error rates, it's serendipity. And there's an industry that has been capable of handling all the circumstances in such a way that it creates kit. But there's still a lot of coincidence involved. And I think it's fascinating. And we rely on these tools.
Yeah, it's true. So, one day, I was so much happy with being a chemist rather than a process engineer at semiconductor fab. It's hard job. Right? It's hard job. It's integrating all unknowns. And, self-made semiconductor process is not that easy. And you really have to understand machines, chemistry, and everything to make it work. So today, my colleagues and Rapids, they are doing a really interesting job. Very integrated.
Okay. You remind me of one of the favorite stories in my book. So you're talking about the voodoo aspect in the chip manufacturing. Well, I encountered one of these voodoo stories. It's kind of a gross story, so I'm happy to share it with you because I'm Dutch. Intel once in one of their Arizona fabs in close to Chandler was encountering a dropping yield every night between 1 and 2 a.m. and they didn't have any explanation, no logical explanation to that. So it took them a month to find out what was happening. And actually, it was caused, this issue, by dairy farms in the neighborhood of the chip manufacturing area. And during the night times, the wind changed and the methane, so cow farts and burps, blew into the air conditioning system of the fabs and the yield dropped and they couldn't filter it out. So the only way to solve this issue was buying out a couple of farms in the neighborhood. And till this day, every time that Intel is looking for a new location for any of the fabs, they first count the cows. Okay, back to my voodoo.
Yeah, actually, it's no joke. The worst place I know is Eindhoven.
Eindhoven, too many cows?
Yeah, no, yeah. Too much methanes or methanes or also ammonia. And our resist chemistry is so prone to those kind of air contamination.
maybe you can tell because there's a lot of emphasis on the horizontal resolution. Okay, this machine does 2 nanometers, 1.4. What's the actual thickness of resist?
Well, like a 0.2 nanometers these days, 0.2 and 0.2 micron. But one thing I was going to say is that always customer blame us first.
Okay.
So therefore, and why long? It's always a resist because it's difficult to understand.
Yeah.
Machines supposed to be, they can see machines, but on resist you don't see it, right? So therefore, if the resist profile doesn't replicate the customers, also, so sometimes they change.
Okay. So because they don't because they can't explain it, they blame it.
Yeah.
Okay. So because we do brutal chemistry. Okay. So you're like the wizard.
Yeah. So anyway, back to our discussion. So really the third phase is that pretty much EUV. I was subtly about it with ASML was spending about 15 years on EUV, before they really start getting more serious about the EUV, application deployment. And I kind of remember that this EUV the R&D started in 2008. I think that time that they promised to deliver a tool to some.
Okay, don't rub it in though.
There also there's some issue with light source, so they acquired Silent, and but also at the same time that all of a sudden up until that time that I think our society, the world was kind of peaceful with global, so we can much enjoy that stuff, pretty much focusing upon technologies. But all of a sudden, after Biden took over the office, and all of a sudden we got involved in politics. I think South made your book, talking a lot about Martin, but also Peter, being a CEO, he has a wonderful job to maneuver or control any potential damages coming from U.S. pressure. So you had an opportunity to observe many of the these moments where you have the smell, and can you share some episode or insight, perhaps not included in this book, that illustrate how leadership shaped ASML trajectory, during the space?
Okay, so let's start with the EUV. I'll divide your point in two separate issues. EUV was a technology that was out there. ASML promised it to go live for high volume manufacturing in 2010, 10-ish, and they had this huge issue with the lag source because it was not capable to create enough power, so the throughput was very low. There's a huge emphasis on resolution in this industry, but chip manufacturers are usually only concerned with throughput and yield. They want to keep stamping because that's where the value is. So if a machine, even though it's capable of writing these very fine patterns, is not capable of having enough wafer runs within an hour, that it's, they're not going to use it. So that was a huge bottleneck for ASML. That took about 10 years to fix this light source issue and to keep these lenses clean, mirrors clean. As I showed you, one of these contained mirrors, it was really an issue. So when they solved it, and when EUV was getting to the this level of economically viability, they came at a cross point with geopolitics, because it was the first advanced technology that was out there, and it was aligning with the fact that AI was becoming important as a technology, and it was deemed to be, well, the determining factor not only for the wealth in a country, but also for building up defense capacity, because the way we do war or do defense is shifting from analog to digital as well. And so ASML became the focal point of a chokehold of this new era of technology. So it made sense to restrict EUV. And if you look at the multilateral agreements, like the Wassenaar Agreement, which is like co-signed by 42 countries, then it makes sense to have these really top-notch technologies, restricted, or these when it's dual use, to have it controlled. And the US used their force, the economic force and pressure and diplomatic pressure on the Dutch government to restrict ASML, because they already sold a machine to China. Back in 2018, actually they sold 2 machines, one via Korea and one directly to SMIC. But they had to tear up these contracts because the Dutch government restricted them. And for the Biden administration, that wasn't enough. And Biden wanted also any kind of advanced litho, everything below 40 nanometers, to be controlled. And that, of course, was hurting ASML, not only for EUV, but also DUV. So less advanced technology, but still capable by doing multi-patterning to create AI chips. And also it affected TEL, the Tokyo Electron. And for ASML to maneuver, are actually going to use that word more often, because I think that's the way to handle these issues. The Americans tend to overemphasize the simplicity of just controlling nations, because this technology is like not easily controlled because there are too many dependencies politicians usually don't see. And Peter Wenning was capable of explaining them. He's a kind of a teacher. So when you speak to him, usually you listen to him for 45 minutes of the hour. And he explains how the semiconductor industry works, and that there's a lot of chips coming from China used in electronics throughout the world. If you restrict China from building them, you're going to hurt your own economic or your own industry, because you can't use any dishwashers, or you can't provide your car industry anymore. So there's a whole network of invisible connections. And Peter was able to explain that. Yeah. But he was also Dutch. So he was blunt. And often in doing these diplomatic meetings, and I'll share you one story which isn't in the book, during one of these meetings he was just too blunt and say he was being accused of the fact that the semiconductor industry was like supporting China mainland's aggression when it comes to some of the inhabitants of China. And he countered that argument by saying, okay, but we're not, it's like the weapon industry and doesn't want to be held responsible for school shootings. And this was kind of hurtful for the US diplomats across the table, because it's like pointing out to the Americans, you have certain shortcomings in your systems as well. I think that's you could think that, but say that bluntly in a Dutch way isn't always conceived as polite. And as you stressed that earlier, I think, especially even though Peter Wenning is not an engineer, he liked the simplicity and clarity of ASML. It has an engineer spirit, and they're very yes means yes, no means no. Be blunt, be clear, because every time you're being polite or want to make up excuses or want to nuance things, you're adding latency. So you're just postponing the decision. Let's move on. Okay, this is what it is. Okay, let's get up. So that spirit kind of often, not always aligns with a diplomatic approach.
Did you I think we can continue talking, but now that you want to take it over and taking some questions from audiences.
Maybe just to ask you specifically, I think one of the main arguments in the book is how ASML and ASML staff has always been pushing the agenda more and more, even though they've been told it's impossible to achieve this kind of new technologies. So maybe in the discussions that you had and what you wrote in the book, what key point was the most kind of the best example of this kind of mentality of keeping pushing that agenda? So can you just highlight one specific aspect?
I'm not an engineer myself, but I got a chance to take a peek at some of the brilliant engineers within the industry, not only ASML. And there's this one explanation that Frits van Hout, he's kind of the raconteur, like the commentator in the book. He expressed this feeling that for a physicist, it's a huge leap to get from 0 to 1. But once you get to 1, you can get from 1 to 10, and you get from 10 to 100, and from 100 to 1,000. So once you make this small step, it's really like the lunar landing, as we discussed earlier. It's a huge, it's just a small step, but it's easier once you've proven that something can be done, then you just have to optimize it. You just have to industrialize it. And ASML has built this this expertise in industrializing, and they realize, okay, if we can do it in this way, then we have the expertise to do it in another way, and to even get to this level of 1,000 watts of EUV lights, and they started off with 5 watts. So that seems like a huge leap, but in an engineer's mind, it's just a small step. Just wait and see.
Thank you for your opportunity. Use your particularity. You talked about the comparison between Japanese and the Dutch company in terms of the perfection trying to reach the perfect or perfect thing. Yeah. That's, I think, the point that we try to make when the project is complete. We make sure that process is permanent, that we are ready. But maybe the approach you just mentioned that maybe since we have this level of perfection, then ASML will pick trick of this and put it in the market. Is this kind of corporate culture, or this is like a kind of Dutch approach?
I think that's an excellent question. So I need time to think about it, because you raised two issues. If you look at let me just take a leap to Taiwan. If you see what's kind of connecting these small countries, Taiwan as an island, or Dutch as a small country of traders, that they need to be communicative. So they need to be able to communicate, because otherwise you're not going to survive as a small country. You have to be able to trade. So communication is a very important aspect of cooperating with your customer and building a bond of trust with such an important tool, because litho is, I think it dropped. Okay, but litho is the most important tool. So you need a huge bond of trust, and the only way to get to this level is communication. So that kind of set ASML apart from communicating in the way that Nikon did at Samsung. They were closing, they were fencing off their technology, and that's one of the cultural aspects. And I think there's also an economical and a strategic element in it, that once you get this machine out to your customers earlier than your competitor, you get the advantage of the first arrival. So you start experiment, you can make more mistakes together, which sounds like a bad thing, but this is actually an industry about doing so many as many data runs as soon as possible, because then you can outpace your competitors. So you need to build up experience. The only way to build up experience is to make mistakes. So one of Martin van der Brink's famous quotes was, we don't try to prevent mistakes, we try to manage mistakes. It's a different business. So by having this perfect enough machine, you get to this level of, okay, let's start tweaking together. Excellent question, man.
Telca's kind of similar culture. Yes. I think they do have similar culture. I know Telco many years taking you prove it so successful listening to customers, and also working with customers. They will try to fix all the issues with the customers. That's why they are successful too.
Yeah, and let me just add one thing. This is not an ASML commercial, because I don't own any shares in it. The company didn't sponsor me in writing this book, but I think one thing that I reminded from one of the managers, he was a leading manager in the book, he explained that often you're complimented by your bosses if you help out a customer by solving a problem, by giving away an expensive lens, for example, or at least so the customer is happy, and not save and be too prudent in helping your customer. So this is the mindset of ASML. The customer is basically always right, unless Martin van der Brink involves, because we don't spare.